Today we are going to combine a retro game, an Atari Grandprix game, with a Python and OpenCV, and we will build a self-driving car. So this is the game. The car is accelerating and brake when another car, it's like an obstacle that comes towards our car. Once again we are accelerating. It's not a optimal self-driving car, but I will explain it later how does it works. So basically we also controlling the keyboard, like going up and down and accelerate and stop. So for example, let's see the coming obstacles, the coming cars, these two cars. In the process we are dividing the screen to two parts. The left part is detecting our car and the right part is detecting the upcoming obstacles, which are the cars. And next I will show the full screen. As you can see, all the parts, like converting the image to grayscale and emphasizing the objects and detecting it and putting a rectangle around each objects. I will explain it, as I said earlier, on a full tutorial. Back to the game. As you can see, the car is driving automatically, goes up and down, looking for an obstacles and change the direction until the end of the game. Thank you. That summarizes our self-driving car of the Atari Grandprix. Stay tuned for the full tutorial. Okay, in order to understand it, let's divide the process to 3 steps. The first step is understanding how can we capture or get a handle of this window. In this tutorial I will run it on a Windows environment, but of course you can run it on a real Atari game console. I explained it earlier in another video, so I will leave a link here so you can investigate it later. As for now, we will explain it on a Windows environment. Basically it should be the same process. So first of all, you have to create a conda environment, and this environment will be named as Grandprix, and it run on the Python 3.8. Then of course you should activate this environment, and you can see that this is my current environment here in the VS Code process. And then we are installing several Python libraries like OpenCV, PyWin32, PyInput, PyAutoGUI, and skKit image. So let's start for understanding how to capture our game window. So we are going to create a function. We will call it a getWindow function, and this function will get an argument which named caption. So what is caption? Caption basically it's a text, a string argument, this name window. So we can see that the text is Stella 6.52 Grandprix, etc., etc. As you can see, this is the same text that is here. So you should put your own text after installing the Stella Atari emulator. So basically, after running this function, it will return the handle of the window. So as you can see here, I'm running the function and printing the handle, and if I'm getting a value above 0, I will set it as foreground. So basically I will give a focus on this window. Let's run it to understand. As you can see, I've got this number. This number is the handle number of this window. If I will exit from the emulator and run it again, I will get an 0 and an error message. Okay, as you can see here, this is the error message. So let's run it again, and as you can see, it's get focused, and basically now it has a new number, a new handle number. It's not important, but what you should understand that this is the process in order to get a handle of a window. Okay, now let's continue to step number 2. And what is the target of step number 2? The main target is to capture our car. This red car here, we have to capture it. We have to understand and to focus and to grab the specific area of the car. But since the car is moving, we have to figure a way how can we detect our car. And as you understand, if you are playing the game, there are many cars that are coming in front of our car. So how can we detect and collect the information of which of the cars is our car and what is the position in the screen? So first of all, let's run it and then I explain the code. As you can see, as first our car, our object is now here, it's moving. So sorry, it's not moving. I had to fix the position of our view. Let's run it again. As you can see, it's on a specific position and it's not moving in order to capture our screen. And here you can see that we are getting the image, we are converting the image to black and white, to a grayscale, and then we are looking for a specific region in our screen. You can see this is the area, so we are looking of this specific region in our view. Once again, let's run it again, sorry. So if this is the game, we are looking on this specific area, and then we are looking for our car, and we are going to use 3 methods in order to understand if this is our car. So let's understand the code. The first part is the same as our previous part, as the step 1, so it's capturing our window. So this is the same as earlier. Then we are going to build a new function that we call it take screenshot, and basically this function is getting the arguments of x, y, width and height, and is looking for this specific area in our screen. So it will create capture our screenshot, and it's going to look for a specific region, convert it to a number array, and convert it to from RGB to BGR, since we are using OpenCV, and OpenCV is based on BGR, and it will return this capture area. So I will skip this function, I will come to it earlier, so same as for the next one, and let's start our program. This is the starting point. So first of all, we are going to get the position of our the dimensions and the position of our window, and now we are going to run a while loop, run our screenshot in order to get the screenshot of the game, set the window as foreground to be focused, get the height and get the width. And now we are getting the array, only the area for our car. So this is the area for our car. We are going to convert it to grayscale, we are going to do a threshold in order to get only the let's say the white areas between 100 and 255, which is of course white. Going to do it as invert. If you run it, you can play with it and understand it. And then we are going to blur it, and now we are going to look for contours, only for external contours. And as for now, we are going to loop inside our contours, and if we are finding a big contour that it's more than 500 area, then we are going to see if this is our car. So you can look at this process and understand it. Basically, we are going to run several methods in order to see if this is our car. The first one we are going to use, one second, where is this function? We're going to check if it is red, since when we are running the game, let's run the game. You can see that there are many cars in many shapes and colors. So basically we are looking for a red car. So this is the function to see if our car is red. Another function is a function of similarity. This is a nice and cool OpenCV function, structure similarity. And I built a short function. You should convert it to a gray and then do a similarity between this car and the one that we captured in our windows. And if all of these let's say check marks are right, then for us this is our car. So we can put a rectangle around it, and we are capturing for the next steps the position of the car. Let's run it again, one second. As you can see, it finds our red car and we have a red rectangle around our car. I'll also have a specific image of our my car, so this is it's relevant for the process of comparing between the capturing image and our car. So this is step number 2. Now we are going to continue to step number 3, which is the full code. Okay, let's continue for the third part. And in this part, which is the full code, we are going to add 2 more complexity. One is how can we detect the upcoming cars or the upcoming obstacles. And the second complexity is how can we add the keyboard. That means how can we accelerate, how can we stop, brake. What I mean is how can we go up and down. So how can we give commands to our game if we are detecting an obstacle coming. So in order to explain it, let's look on this image. So in our first phase, we look on this area, and in this area we looked for our car. Since this is our car, sometimes it can be up, it can be down. So the main process of the previous step is looking for our car, and if we are understanding this is a car, how can we double check which of the cars we are seeing in the image? Is it our car or a different car? And we did it by looking for the color and looking for similarity and doing many types of double checks in order to understand that this is our car. This is, for example, not our car, but if this blue car can be in this position, we can see here two cars in this area. So how can we understand that we are looking for our car and we are checking where is the position of our car? So this was the previous step. Now we are going to look on this area, which is named as the rest of our interest of the region of interest, and we are going to look for obstacles. And after we are going to look for obstacle and understand if we are finding an obstacle, we're going to see if there is a close gap or a large gap between our car and the upcoming car. And if the obstacle is near, we are going to brake. And if the obstacle is not near, that means that we can accelerate. Moreover, if there is an upcoming car, we would like to move the car for example, in this process, we have to go it down. So how can we decide if we have to go down or up? So in this code, if we are finding an obstacle, we are going to look the gap between the upper position, the upper position of the game to the obstacle, and from the obstacle to the down position. So if this area is bigger than this area, that means that the red car should go down. So basically this is the main process. And now let's jump to the code. I'm not going to code it as a freestyle, I'm just going to explain our code. So the first process is detecting our screen, our game screen, and capturing our window. And let's move forward to the place that we called it here, the rest of the area. The rest of the area, as you can see, I'm looking for ROI rest. What is ROI rest? If I go back to our image, ROI rest is here. This is the place for ROI image. So this is this area. Now we are going to collect the width and the height. We are going to convert it to gray. Threshold, the same as the previous process. We are going to blur it, so it will emphasize our upcoming cars. We are going to find contours in an external process. That means that it's going to look only for these contours and not going to look for inside contours. Then we are running a loop inside these contours. Now we are going to look for a contour area that is bigger than 500, not 5000, since if you played the game, you can see that there are smaller obstacles, so we would like to detect them as well. Each time we are finding an obstacle, we are going to append it inside an array. Here you can see that I'm defining it here. And if we are finding an obstacle, we are going to draw a rectangle around this obstacle. In this code, we are looking for the best area. What is the best area? As I said earlier, if the obstacle is here, so this is the best area. I'm going to define this best area, and for this car, for example, this is the best area. That means that if this is the best area, we are going to give command for the car to go down. Okay, now it's the commands for the car. We are going to accelerate. Space is accelerate in this game, and this is the press. After 0.2 seconds, we are going to release the space. That means that we are going to click the space and release the space, as I'm do it like a human behavior. And from here we are giving the commands for the car. For example, if there isn't any obstacle, we are basically doing nothing. Doing nothing, that means that we are still accelerating. And now this is the command for go up. So first of all, if we understand we have to go up, we are clicking left. Left, that means do a short break, and after doing a short break, we are going up along with space, because the game needs to accelerate in order to go up. The same for down. So basically you can cover the code later, and basically that's it. I'm showing here all the images. As you can see, I can run the code. Let's run it. Okay, so as you can see, the car is accelerating. I will move this. So here in this process, you will see each time there is an obstacle. Okay, you can see that it's detecting the obstacle and drawing a rectangle. And now it brakes and go down. Now it's a freeway, so it's still accelerating. Now it's going down. Okay, that's it. Thank you very much, guys. Bye bye.